Hi everyone. So today we're going to finish lesson 5 and we'll be finishing this unit. So this is lesson 5 part 3 and then we'll have a summary. Here I'll have a handout for you today. Well, let's refer back to this software which you can see the changes of the linear function dynamically. Like as you move the function you can see the corresponding reciprocal function, how does it look like, right? And then like this is the linear function, there's only two cases, the positive slope or negative slope. This is how it looks like. And then for the quadratic, it will look like this. This is the first case where you have three parts. Like you can see the blue has three parts and you have four invariance points. As you move the graph up, it created all the 7 cases. 1, 2, 3, 4, 5, 6, 7, right, like this. And then this is the first case. The second case is they just touch at one point. So now there's only 3 invariance points. The third case is there's only 2 invariance points. Here they don't touch, but you still have the bottom part. The fourth case is when the entire graph is above the exact x-axis, then you don't have the bottom part anymore, and then you only have 2 invariance points. This is the fourth case. The fifth case is, but you still have an asymptote, vertical asymptotes in the middle. See, the two parts are separated. But then the fifth case is when it's no longer separated, they're connected in one piece, there's no vertical asymptote because the graph do not touch 0 anymore. And then the sixth cases is they share the same common point, one invariance point instead of 2. Finally, they don't have any invariance point as well. Okay, so I'll summarize it all in the handout today. Okay, so let's go to this handout. So for the two linear function, like you have two cases. Here we go, and then we will fill in the blank. Okay, so look at this graph. So to relate the two graphs, you identify the zeros. The 0 here is at 3, 0. And what does that become? It's become an asymptote here, which is at x equal to 3. Okay, 3, 0 become x equal to 3. There's always a horizontal asymptote at y equal to 0. So there's always horizontal asymptotes here. And where are the invariance point? When the graph hit 1 and negative 1. So they looks like 4, 1 and 2, negative 1. So 4, 1 and 2, negative 1. Whenever the y value is 1 and negative 1, they are the invariance point. So this is the linear case. And you can go the other direction. The zeros here is at negative 1, 0. So therefore, the vertical asymptote is x equal to negative 1. There's always a horizontal asymptote as y equal to 0. So there's always one here, and there's one here, as you can see. The invariance points are here, which is negative 2, 1, and 0, negative 1. Negative 2, 1, and 0, negative 1. Whenever the y is 1 and negative 1, there it will be an invariance point. Okay, so complete the notes here. Now let's move on to reciprocal function. So it has 7 cases. So let's start with the basic graph. It looks like this, all right? And then we will continue to move the quadratic up until the vertex is at different location. Here, the vertex is at 3, 4. Here is at 3, 1, all right? And then we'll further move it up to be at 3, negative 1.5. As you see here, it will become negative 2 because when you flip negative 1.5 become negative 2. And then there's one at it just touched 0. And then you keep moving on. It's located at 0.5, at 1, and above 1. Okay, so the 7 cases is created by just moving the graph up, by changing the vertex, just moving it up, and you create all 7 cases. Okay, let's look at the first cases. Back to the first cases. When you have this, so how would you describe it? How many vertical asymptotes are there? Well, there are 2. One at here and one at here. So they cross 1 and 5. So they cross 1 and 5, and it becomes your 2 horizontal vertical asymptote. The horizontal asymptote is always the x-axis. There's always 1 there. And how many invariance point here? Well, let's check. 1, 2, 3, 4. So there are 4 invariance point at 1 and -1. The final thing we can talk about is this point is 3, -4. When you take the reciprocal of the y value, it's become 3, -1 over 4. This is where this point is. And then you connect the other points with a curve, and then you get the reciprocal function. Okay, so this is your first case. The second case, still, there are 2 vertical asymptotes at 2 and 4 right now. At 2 and 4 right now, there's a horizontal asymptotes here. How many invariance point? In this case, there's only 3 invariance point. 1, 2, 3. Okay, and this point stay where it is. Now, keep going. All right. So now you move further up. So how many vertical asymptotes are there? There's still 2. So like somewhere there and somewhere there, right? So there's two vertical asymptotes at 0, but only 2 invariance point in this case. The minimum point, the vertex of this graph, now you take the reciprocal of this number, it becomes 3, -2 as shown. Okay, so this is your new point. And then you draw the curve accordingly. All right. So again, everything you can put in a graphic calculator. You can graph this function, f of x, as your y1, and in your y2, you just graph 1 over f of x, and you will see the blue graph. And this whole unit is about learning, understanding what it is, and how to connect the two, how to draw them, how to solve problems involving them. Okay, next, moving further up, your graph is completely above the axis. There's no more negative, so there's nothing here. Okay, so that's the difference. So how many vertical asymptote? Well, there's one vertical asymptote because you have 1, 0 right at 3. So that's separating the two graph into 2 pieces. Like we know the vertical asymptote has the equation x equal to 3. How many invariance point? 1, 2. So there are 2 invariance points in this case. No more graph below the x-axis. The 2 reciprocal curves do not touch as separated by the asymptote. X equal to 3. Okay, so that is your graphs, and then you just make two curves here, right? Approaching your asymptotes. The asymptote is always like the guide to bound your curves, or like to give you a guide where the curves go, and it will cross the invariance point. Okay, 3 last cases here, and then we will go to our workbook to solve some problem. Okay, so moving further up, no more 0, so no more vertical asymptotes because there's no more 0. You still have 2 invariance points. And then this point is like 3 and then 0.5. You take the reciprocal of this number, become 3, 2. So this point here is 3, 2. Okay. Now, the next case is we move it further up so that this point and this point actually become one point, become the invariance point. No vertical asymptotes. There's only one invariance point right there. So this point stay there. That's your invariance point. It's your minimum point for your f of x function. It's the maximum point for your g of x function, which is defined to be the reciprocal of f of x. Finally, this case, all right, this is your f of x. This is your reciprocal graph. They don't touch anymore. There's no more vertical asymptotes. There's no invariance point. This point 3, 2 become this point 3, 1/2. Okay, so that's show you all the cases with reciprocal function. Okay, so complete the notes. Okay, so I will close this. Now in here, go back to our notes. And we saw this yesterday. Like this is like the summary. Like in here, suggestions for making a graph. Like for us, we just make like 3 points. Here they break it down into 5 points. So what's the difference? We can take a look. The first one is the same as ours. 0 become vertical asymptote. Number 2 is same as ours. Invariance point at 1 and -1. Number 3, our third point, we just say make a curve, right? Complete the reciprocal graph, just make a curve. In here, they added, you graph the y asymptote, whatever y asymptote, let's say the y asymptote is, oh, sorry, y-intercept is at 3, it will become 1 over 3. That will become the new y-intercept. And then also, they look at the maximum minimum point. Let's say you have a um, um, minimum point at 2 in your original graph. Now it will become your maximum point of 1/2 in your reciprocal graph, and so on. So they just added this detail in the steps, which we also did when we do the graph. So let's look at some example. Okay, we are on page 482. Let's look at this example. So if you think about this, what case is this? This is the case 4. Okay, so they tell you the y-intercept is at 3. So if I make a graph, how do I make it? First, 0 become asymptote. So I have an asymptote as x equal to 2. I have a horizontal asymptote here. It will be my guide. How many invariance point? 1 and 1. 1 and 1 is the invariance point. There's 2 invariance point. Well, let's make it more accurately. Rather than just making a curve here, there, let's make it one more accurate point. Your y-intercept at 3, it will become 1/3 here. So now let me connect my graph. It go through the new y-intercept, go through the invariance point, approach the asymptote, right? This is another one. Just go through here, roughly there. It will be symmetrical. This will be my answer. You can use your graphic calculator to see, right? They tell you this is the function of this curve. And if you put it in a graphic calculator, 1 over this function, you will get what we just draw there. Okay? All right, so it is similar to case number 4 that we have. So let's look at this one. This is the normal case, case 1, but then upside down. This is case 1. It has a maximum value of 2, so which is here. So if you now take the reciprocal, become 1/2. Well, let's follow our steps. 0 become what? 0 become vertical asymptote. So we have some vertical asymptotes here. We can write the equation x equal to 1, x equal to -2, where they cross. There's a horizontal asymptotes here. It divides everything into 6 region. Let's mark the invariance point, which is at 1, 1, -1, -1. Okay. And also this point, it goes here. Okay, as it says here. It says here. Now let's complete the graph. Okay, over here, I will complete this part. Go through here. Here we go. And then on this side, all right, it will go through here, go through this point, coming down. Finally, you have a graph that go from the top. Okay, it will go from the top. It will make a pen. Right? We want to draw something. Or we want to erase something, otherwise it won't let me draw. So let me erase this bit. Okay, let's draw. So I will have a curve coming down from the asymptote, cross this invariance point, cross this minimum point, cross the invariance point, and coming back there. Okay, so I hope you get the idea, right? With all the summary and everything, I hope you get the idea. Now, one more example. Okay, and then we'll be done. Okay, so I think I need to make another video very shortly. Like the other video is just like couple minutes to cover the last example here. Okay, all right.